So, so let's do some solution stoichiometry. So it's just like stoichiometry, except we're doing stuff in aqueous solutions, and we're going to use molarity, which is one thing about that. The only difference is the way we get to moles. So anytime we have stoichiometry, we have to get to moles. The only difference is how we get to moles. In this case, we're going to multiply the molarity, which is moles over liters, by the volume in liters, and that's going to give us moles. So we always got to get to moles. In this case, it's molarity times volume in liters, and that gives us moles. So let's take a look at this problem right here. It says how many grams of silver chromate, so this is going to be our precipitate, will precipitate when 150 milliliters, so 150 milliliters of 0.5 molar silver nitrate is added to 100 milliliters of 0.4 molar potassium chromate. So this is a limiting reagent because they give you the amounts of both reactants. So we're going to work them out separately. So let's do it first for the silver nitrate and figure out if all my silver nitrate reacts, how much silver chromate is going to be. When you're doing this, I change this volume to liters. So let's just move the decimal over 3 places. So 1, 2, 3. So this is liters of solution. I'm going to convert this to moles, so I'm going to multiply by the molarity of silver nitrate. This 0.5 m, big M means 0.5 moles. Over 1 liter of solution. Now I got moles of silver nitrate. Well, once I got moles of silver nitrate, I know that 2 moles of silver nitrate will form 1 mole of silver chromate. So it's a 2-to-1 ratio. And then we change the grams using the molar mass. I think the molar mass is 331.74. So 1 mole. So if I do that, I'm going to get 12.4 grams. Silver chromate. So if all of it reacts, I'm going to get 12.4 grams of silver chromate. Now I'm going to do the same thing now, except for part B now. I'm going to use 100 milliliters and 0.4 molar potassium chromate. So I went ahead and kind of worked it out. So again, I'm changing this milliliters to liters. So 1, 2, 3, 0.1 molar solution multiplied by the molarity. So in this case, it's 0.4 big M. It's 0.4 moles over 1 liter. It's a 1-to-1 ratio. 1 mole potassium chromate forms 1 mole silver chromate, and then I change the moles to grams. When I do that, I'm going to end up with 13.3 grams of silver chromate, and then we make the comparison. We always circle the smallest amount. So the actual amount is going to be 12.4 grams of silver chromate. So we have enough of the silver nitrate to produce 12.4 grams, and then the reaction stops. So even though I have some excess potassium chromate, I don't have enough silver nitrate to do it. So in this case, the silver nitrate, that's our limiting reagent. So no different than we did before in terms of limiting reagent, except the way we got to moles is just slightly different. So let's take a look at this second one. In this case, how many grams of aluminum are required to react with 35 milliliters of 2.0 molar hydrochloric acid? So again, we have our balanced chemical equation. The thing is, we want to get to moles of something. What I want to have to do is, if I multiply the volume of hydrochloric acid by its molarity, I'm going to get moles. So normally when you start these problems off, try to look at one of these reactants or products that has a volume and molarity. You multiply those two together, that's going to give you moles, and then you go from there. So a couple of things what I'm going to do with this, I got to change this volume to liters. And remember, it's because the 2.0 molar means 2.0 moles over 1 liter of solution. So I got to change this volume to liters. So again, it's divided by 1,000. You can move the decimal over 3 places to the left, same thing. Now once I got that, I can multiply by this. So 1 liter. So now I got my moles of hydrochloric acid. Now I'm going to use my multimole ratio. 6 moles of HCl is going to react with 2 moles of Al. I need to get grams of aluminum. Well, I'm just going to use a mole of mass. 1 mole of aluminum is 26.98 grams of aluminum. You're going to end up with 0.6, I think I worked it out, 30 grams of aluminum. So stoichiometry is so important for this class. In this case right here is how we get to moles. Multiply the volume times the molarity. The volume has to be in liters, multiplied by molarity, you got the moles, and then goes mole to mole ratio, etc.